Hello students, welcome back to the maths class. In today's class, let us discuss about product of two vectors. So multiplication of two vectors is defined in two ways. That is, one is scalar or dot product of two vectors, and the second one is vector or cross product of two vectors. Okay, so we have two types. One is scalar product and the other one is vector product, which is also called as dot product and cross product respectively. So as the name says, when you multiply two vectors, if the resultant is a scalar, that is a real number, then that product will be called as scalar product. And when you multiply two vectors, if the resultant is a vector, then it will be called as vector product or cross product. In today's class, let us discuss about the scalar product or the dot product of the two vectors. So, here I will be considering two vectors, say vector A and vector B, which are non-zero vectors. That is, these vectors are non-zero. Then the product of these two vectors will be denoted as A dot B. Okay, we denote it as dot product of two vectors is denoted as A dot B, and this is defined as vector A dot vector B is equal to magnitude of vector A into magnitude of vector B into cos theta. So if you have two vectors, say this is vector A and vector B, the angle made by this is theta, then the dot product of the two vectors, that is vector A dot vector B, is defined as magnitude of vector A into magnitude of vector B cos theta. So we can write this as the scalar product of two non-zero vectors, vector A and vector B, denoted as A dot B, is defined by A dot B is equal to magnitude of A into magnitude of vector B into cos theta. Okay. With this definition, we have few observations. So let us discuss the observations one by one. So please make a note of the definition and the observations which we are going to discuss now. So with these definitions and the observations itself, we are going to solve the problems. So first observation is that the dot product between the two vectors is always a real number, or we can say it is a scalar quantity. It is a real number. This is the first observation we have made. Then, second observation, vector A dot vector B is equal to 0. Hence, the dot product between the two vectors are 0. This implies what, or when I multiply two vectors, the resultant will be 0. You have two cases here, where the first case is when either vector A is equal to 0, means out of the two vectors, if any one of the vector is a 0 vector, okay, then The dot product between these two vectors will be what? A 0. So either A is 0 or vector B is 0. Means one of the vector is 0, then this implies that the dot product between the two vectors will be definitely equal to 0. What is the 0 vector here? Remember? Zero vector is that vector which has got its initial and the terminal. The initial and the terminal point coincide. So zero vector we denote it as, if A is a zero vector, then this vector is denoted as, zero vector is denoted as 0 I cap plus 0 j cap plus 0 k cap. Can you tell me what will be the magnitude of the zero vector? That is, if I take a magnitude of zero vector, it is nothing but again a zero itself. Root of 0 square plus 0 square plus 0 square. So it is 0. So this is a 0 vector and the magnitude of a 0 vector will be always 0. So the first condition we have seen, where if I say the dot product between the two vector is 0, then it is understood it is possible only when either one of the vector, that is either A vector should be a 0 vector or vector B should be a 0 vector. The second case is that the dot product of the two vectors is equal to 0 even when any one of the vectors is not a 0 vector. That is, if A vector and B vector are non-zero vectors, okay, if A vector and B vector are non-zero vectors, but angle theta between them is 90 degree. Okay, hence these two are actually not a zero vector, but if I take the angle between these two vectors are 90 degree, then again the dot product of these two vectors will be a 0. How? See, just now we have defined what is vector A dot vector B. According to the definition, it is magnitude of vector A, magnitude of vector B into cos theta. So here, when I say theta is equal to 90 degree, means this will be magnitude of vector A, magnitude of vector B, cos 90. What is cos 90? The value of cos 90 is what? 0. Therefore, 0 into any vector will be equal to 0. So, when we say that the vector A is perpendicular to vector B. Now, this is how we define. So, when the two vectors are perpendicular, then we say that the dot product between the two vectors is 0. I hope you have understood. If A and B are non-zero vectors, but theta is equal to 90 degree, then this implies A dot B is equal to 0. That is, A dot B is equal to 0 implies vector A is perpendicular to vector B. This also implies that if the two vectors are perpendicular, definitely the dot product between these two vectors is a 0. Okay, this is very, very important, especially this one. You should remember this. If I say that the dot product between any two vectors is 0, this implies that the two vectors are perpendicular, or if the two vectors are perpendicular, then definitely the dot product between the two vectors is 0. So next, third observation, let us see what happens if theta is equal to 0. If theta is equal to 0, then what happens? This is the definition we have. So, when theta is equal to 0, then this becomes vector A dot vector B cos 0. What is the value of cos 0? The value of cos 0 is 1. Therefore, 1 into vector A, magnitude of vector A into magnitude of vector B. Therefore, this becomes magnitude of vector A into magnitude of vector B. If theta is equal to 0, then vector A dot vector B will be equal to magnitude of vector A into magnitude of vector B. What does this say is, if I take a vector A Okay, I'm actually overlapping on another vector, which is vector B. Means this white line is vector A. Next, I'm overlapping a vector B on a vector A. So the angle made by these two vectors is what? It is 0. Therefore, under that condition, the dot product between the two vectors will be directly given as vector A, magnitude of vector A into magnitude of vector B. In particular, if vector A dot vector A in particular, and vector A dot vector A will be equal to what? It will be equal to magnitude of A into magnitude of A, which is nothing but magnitude of A the whole square. So remember this also, vector A dot vector A is equal to magnitude of vector A the whole square. Okay, next let us continue with the few more observations. So here the next observation which we are going to discuss is the fourth one. So in the fourth observation, here we have studied what happens if theta is equal to 0. Now let us see what happens if theta is equal to pi or 180 degrees. Then can you guess or can you simplify and tell me what will be the value of vector A dot vector B? So, when theta is equal to 180 degree, then this will be cos 180 degrees. What is the value of cos 180? It is equal to minus 1. Therefore, this will be equal to minus of magnitude of vector A into magnitude of vector B. So, when theta is equal to pi, then vector A dot vector B will be equal to minus of magnitude of vector A into magnitude of vector B. Again, in particular, okay, same thing. If A dot A, again in the case of when theta is equal to pi, then A dot minus A will be. Why? Because see here, vector A is this. What is the negative of this 180 degree means we are taking another vector, say vector A, but it is in the opposite direction. Then the dot product between these two vectors, vector A dot minus of vector A, the negative vector, let us same magnitude but opposite direction, then this will be equal to minus of magnitude of vector A, magnitude of into magnitude of vector A. Therefore, A dot minus of vector A dot minus of vector A will be equal to minus of magnitude of vector A the whole square. Remember, even this. In this case, what happens? In this case, theta is what? Theta is equal to pi. Here, when I say A dot A is equal to magnitude of A square, in this case, theta is 0. Theta is 0. Here it is, theta is equal to 180 degree. Here the theta is 0. Next, let us move on to the next observation. Yes. Okay, the observation will be now based on these two observations. That is the second one and the third one. Now let us consider the mutually perpendicular unit vectors. I cap, J cap and K cap. Okay. So here, when I say vector I dot vector I, unit vector I cap dot unit vector I cap, what happens? See here, unit vector I cap on unit vector I cap means definitely the angle between them is 0. When the angle between them is 0, then A dot A becomes what? Magnitude of A the whole square. So here I dot I cap means it will be magnitude of I cap the whole square. I cap is what? I cap is a unit vector. Unit vector means the magnitude is equal to how much? It is equal to 1. Therefore, I can just conclude that I cap dot I cap is equal to 1, which is same as j cap dot j cap. Even j cap dot j cap means on j cap I am overlapping again another vector, say j cap itself. Okay, the unit vector, the angle between them is 0 there. So j dot j will be equal to magnitude of j the whole square. Since j cap is a unit vector along the y-axis, we know that the magnitude of any unit vector will be equal to 1. Therefore, j dot j and even k cap dot k cap will be definitely equal to 1. Next, what happens when I take I cap dot j cap? So, if this is our x-axis, y-axis and z-axis, I cap is the unit vector along x-axis, j cap is the unit vector along y-axis, and k cap is the unit vector along z-axis. How these axes, they are actually mutually perpendicular to each other. Means definitely the angle between x and y axis is 90 degree, y and z axis is 90 degree, then even z and x axis is 90 degree. We have just now seen if the angle between the two vectors is 90 degree, then the dot product between those two vectors will be equal to what? It is equal to 0. So, I cap dot j cap, which are mutually perpendicular to each other, definitely the angle between them is equal to 0. Similarly, even j cap dot k cap, when you take j cap dot k cap, again the angle between them, because they are mutually perpendicular, angle between them is 90 degree. Again, the dot product between them should be equal to 0. Same way, k cap dot I cap, again the angle between them will be definitely equal to 0. Remember this, we will be using in formula. Again, this is important. All the observations are important. Okay, this is about mutually perpendicular unit vectors. Now, let us see the next observation, that is the angle between the two vectors. Angle between two vectors, say vector A and vector B. Again, these two vectors are non-zero vectors. Angle between the two vectors and B, which are non-zero vectors, then cos theta, the angle between them. This we have derived from the definition itself. So I just write again the definition here. Vector A dot vector B is equal to magnitude of vector A, magnitude of vector B into cos theta. If I need to find the angle between the two vectors, I can easily write from the same definition. So cos theta will be equal to vector A dot vector B whole divided by magnitude of vector A into magnitude of vector B. So cos theta will be given by vector A dot vector B whole divided by magnitude of vector A into magnitude of vector B. This again you should remember. Okay, so in this one more thing, when you are mentioning dot product and cross product, dot you should specify this, means you should write this dot. You cannot write just vector A, vector B, which is not understood as a dot product. So when you are writing dot, you should highlight that dot whenever you are writing. And as I said, even the vector symbol should be written. Okay, these are the main observations. Here some more observations are there. Let us discuss after this. Next observation. Scalar product is commutative. So here, that is the dot product between the two vectors, means vector A dot vector B is same as vector B dot vector A. So if you consider any two vectors, And if you find the dot product of these two vectors, definitely the dot product between the two vectors is say vector A dot vector B is equal to vector B dot vector A. Again, an important observation. Similarly, next scalar product is distributive over addition. Scalar product is distributive over addition. So if we have three vectors, then vector A dot vector B plus C can be written as vector A dot B plus vector A dot vector C. Remember even this. So vector A dot vector B plus C is equal to vector A dot vector B plus vector A dot vector C. Next, ninth observation is vector A and vector B are two vectors and lambda is any scalar. Then, okay, lambda times vector A dot vector B is equal to same as lambda times vector A then dot vector B, or else this is even same as vector A dot lambda times vector B. Now I'm speaking about dot product. We are finding the dot product between the two vectors. But how actually we can find a dot product when the vectors are given in the component form? Let us see. So here, if vector A and vector B is given in its component form, that is, vector A is equal to A1I cap plus A2J cap plus A3K cap. And vector B is equal to B1I cap plus B2J cap plus B3K cap. If you have any two vectors in its component form, so the general component form I have written, then we find the dot product between the two vectors. How? We just multiply the I component with the I component. That is, see here, A1I cap plus A2J cap plus A3K cap dot, then you have B1I cap plus B2J cap plus B3K. So it is just a multiplication how we do in algebra. So here in the same way actually we are proceeding. A1I cap dot B1I cap. So this will be A1I cap dot B1I cap. This is the first multiplication we are doing. So when I do, I dot I will be equal to what? You can just remember, or you can just see the observations which I had written. I think it is the fifth observation where I have written I dot I is equal to what? 1. So directly I can write vector I dot vector I is equal to 1. Therefore, just I can multiply only the scalar component of it and write A1 into B1. Next, when you multiply this with this now, that is A1I cap, when I am multiplying, it is a dot product between B2J cap. When I do this, see I get I cap dot J cap. I cap dot J cap, the value of this is equal to 0. Therefore, A1 B2 I cap dot J cap will be equal to 0. Therefore, in the dot product, we are not going to multiply everything. So it is understood. So when I multiply A, that is find the dot product between A1I cap dot B2J cap, the value will be equal to 0. Similarly, when I find dot product between A1I cap into B3K cap, I cap dot K cap, you will get again the value will be equal to 0. So it will only end up with, next when you see A2j cap dot B1I cap, it will be equal to 0. Even j dot I is equal to 0 because the dot product is commutative. Therefore, this can be even written as I dot j and the value of I dot j is 0. Therefore, so when you do this, you get only A2 dot B2 plus next it will be only A3 B3. So when we are finding a dot product, we can directly write it. You can directly multiply A1 into B1 plus A2 into B2 plus A3 into B3. This is how we find the dot product between the two vectors when they are given. The two vectors are given in its component form. Okay. Next, you have one more concept here, that is the projection of one vector on another vector. Let us see that. Next concept, it is projection of a vector. So, this is, let me take it as vector A. Next, this I call it as vector B. The angle between them is theta. Okay, I name this as A, this is B, and this I name it as C. We know how to define the dot product between the two vectors. It is vector A dot vector B is equal to magnitude of vector A into magnitude of vector B into cos theta. Okay. So here, when I need to find the projection of a vector, that means, see, if you see vector AC, that we even written it as vector B. What is the projection of this vector B on the vector A? How much it is getting projected? How much this vector B is getting projected? This is what we are going to find. Okay. Here, before actually finding that, I just rearrange this definition. This definition can also be written in the form vector A dot vector B by magnitude of vector A, which is equal to vector B into cos theta. Yes, so here vector A dot vector B by magnitude of vector A can also be written as vector B by cos theta. I am telling that this is nothing but the projection of vector B on vector A. This magnitude of vector B into cos theta is nothing but projection of vector B on vector A. I should make you understand here. So now what I do is, I draw a perpendicular from this point C. So if I draw a perpendicular, I'll get a right angled triangle. The projection of this vector on the vector A, this is only so much again. So this I'll call it as some value P, some point P. Okay. From this right angle triangle, I am going to define what actually cos theta is. So cos theta is given by adjacent by hypotenuse. So here adjacent, so for the angle theta, this side will be your opposite, this is your hypotenuse, and this will be your adjacent. So what is your adjacent? Adjacent is nothing but AP. It is only AP. This entire thing is vector. Adjacent is nothing but AP whole divided by adjacent by hypotenuse. What is your hypotenuse here? It is nothing but vector B. But I am taking hypotenuse, it is only a number, it is only a scalar quantity. But I can't write a vector here. So I will be considering the magnitude of the vector B. So when I cross multiply this, vector B into cos theta is equal to AP, where AP is actually the length, AP is actually the projection made by the vector B on vector B. So when I take this, if I project it, then AP will be the projection of vector B on vector A. So magnitude of B into cos theta will be called as the projection of the vector B on the vector A. So here therefore I have called this as that is magnitude of vector B into cos theta, we call it as projection of vector B on vector A, and the formula is given by vector A dot vector B by magnitude of vector A. This you should remember, this is very important. Projection of what vector on what vector. If they ask what is the projection of vector A on vector B, then your formula will be vector A dot vector B by magnitude of vector B. Okay, so you just remember on what they have given, that vector should be in the denominator with its magnitude. You can remember like that. So usually two vectors will be there. You can just the dot product of the two vectors. When you are writing divided by, you should be careful on what it is there. On what vector it is there, that magnitude you should write it in the denominator. So this is about the projection. So whenever they ask what is the projection of a vector A on vector B, it will be equal to vector A dot vector B by magnitude of vector B. Then if they ask what is the projection of vector B on vector A, then it will be vector A dot vector B by magnitude of vector A. Okay, so this is about the concept of the scalar product or the dot product between the two vectors. So we have learned about the definition and the observation and also the projection of the vectors, or the definition and also the observation and even the projection. Everything, these are all key points we will be now using in the problems. Okay, now let us solve problems. The first problem is we need to find the angle between two vectors, vector A and vector B, with magnitude 1 and 2 respectively. That is, the magnitude of vector A given as 1 and the magnitude of vector B is given as 2. And when vector A dot vector B is equal to 1. So given data is magnitude of vector A that given it is equal to 1 and magnitude of vector B that given it is equal to 2, and also they have given what is vector A dot vector B which is equal to 1. We need to find angle between the two vectors. So we are seeing what is the formula for angle between the two vectors. So angle between the two vectors is given by cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. So let us substitute the given data. So vector A dot vector B is given it as 1 divided by magnitude of vector A, it is 1 into magnitude of vector B, it is given it as 2. So this is 1 by 2. We need to find what? We need to find what is the angle. Therefore, theta is equal to cos inverse of 1 by 2. Okay. Now, this is equal to cos inverse of, for what value of cos you get it as 1 by 2? It is cos 60 degrees. So, cos pi by 3. Therefore, this will be equal to pi by 3. Okay, next you have the next question, which is the same question, only the numericals are changed. Again, we need to find the angle between the two vectors, where vector A and vector B with the magnitude. So the magnitude of vector A is given it as root 3 and magnitude of vector B they are given it as 2, and dot product between the vector A and vector B is given as root 6. So we know that cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. Therefore, this is equal to magnitude of vector A dot vector B is equal to root 6. Magnitude of vector A is root 3. Magnitude of vector B is 2. Therefore, this can be written as root 6 can be written as root 3 into root 2 divided by root 3 into 2. So root 3 get cancelled. So root 2 by 2 can be written as 1 by root 2. So this is our cos theta. We need to find what is theta. So theta is equal to cos inverse of 1 by root 2. So this can be written as cos inverse of 1 by root 2. So cos 45 degrees, cos pi by 4 is 1 by root 2. Therefore, the angle between them is 45 degrees in the second problem, and in the first problem it is 60 degrees. Next problem, we need to find angle theta between the vectors. So here the vectors are given in component form. So what is the formula for angle between the two vectors? It is cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. So first let us write what is vector A. Vector A is given by I cap plus j cap minus k cap dot this dot. Then vector B. Vector B is given as I cap minus j cap plus k cap divided by. Now what we need to find? We need to find the magnitude. We have already seen how to find the magnitude of any vector. How? It is root of x square plus y square plus z square. So here root of. So magnitude of vector you should find for a vector A. So what is the x value here? It is 1. Y value it is again 1. Z value it is equal to minus 1. So x square, so it is 1 square plus again y square which is 1 square plus z square. What is z here? Minus 1 then whole square. So this is the magnitude for vector A. Similarly, we need to find magnitude for vector B. So this is vector B. So here what is the x? It is 1. Y it is minus 1. Z it is plus 1. So how to find magnitude? 1 square plus minus 1 whole square plus 1 square. Understood till here? Now next step. Here I need to find the dot product. So when I need to find the dot product, as I just now said you how to find, when you have any two vectors in its component form, then the dot product between these two vectors is a1 b1, multiplying this into this, plus a2 b2. That is j components of both the vectors you are going to multiply. Then plus next k components a3 b3. So here what you should do? Here what is the component? The coefficient of I cap here is 1. 1 into 1. It is 1. Finish. That's all. A1 only I component with I component. Finish. Next you should move to j. So it is plus 1 into minus 1. What is plus 1 into minus 1? It is minus 1. Finish. J component is finished. Next go on to k. When you go to k, minus 1 into plus 1. It is minus 1. Understood? Divided by. Now this will be equal to 1 square plus 1 square plus 1 square. Root 3. 1 plus 1 plus 1, 3. So root 3. Again you have root 3. Plus 1 minus 1 get cancelled. So you have minus 1 divided by root 3 into root 3 whole square, which is equal to 3. This is cos theta. Therefore, theta is equal to cos inverse of minus 1 by 3. You can just leave it here. I hope you have understood how to find the dot product between the two vectors when they are given in its component form. Let us take up the next question of the same kind. So here again we have got two vectors. By applying the same formula, again following the same step, we should find what is the angle theta. So here vector A. So they have not mentioned which is vector A and vector B. You just take the first vector as vector A and the second vector as vector B. So vector A is given by I cap minus 2j cap plus 3k cap. And vector B is given by 3I cap minus 2j cap plus k cap. We need to find the angle between the vectors. So formula is given by cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. So let us simplify by substituting first the vectors. So vector A is given by I cap minus 2j cap plus 3k cap dot dot product. Then vector B. Vector B is given by 3I cap minus 2J cap plus K cap whole divided by magnitude of vector A. So magnitude means as well as your magnitude, it's right root of. So root of. So here x is 1, y is minus 2, z is 3. So it will be 1 square plus minus 2 the whole square plus 3 square. That will be the magnitude for vector A. Next, let us find what is the magnitude for the vector B. So they have asked us to find magnitude, we are finding. So here also magnitude of vector B we need to find. Here x is 3, y is minus 2, z is 1. Therefore 3 square plus minus 2 whole square plus 1 square. Simplifying further. Now we need to find the dot product in the numerator for this problem. So here, what you should do? What is the I component here? Means the coefficient of I here, it is 1. Here it is 3. 1 into 3, 3. Finish. Next move to J. So here it is minus 2. Here also it is minus 2. Minus 2 into minus 2, it is plus 4. So plus 4. Next K. Plus 3 into plus 1. It is 3. Divided 1. Root of. So here it will be 1 plus 2 square 4 plus 3 square 9 into root of 3 square 9 plus 2 square minus 2 whole square is also 4. So then 1 square it is 1. Therefore this is equal to 6 plus 4 10 divided 1. In the denominator you have root 14 and also here you have root 14. Root 14 into root 14 that's just 14. Root 14 whole square which is 14. Therefore this will be equal to 5 by 7. I am going to continue here. So cos theta is equal to, simplifying this, 10 by 14 can be written as 5 by 7. Hence theta is equal to cos inverse of 5 by 7. Let's end till this problem for today's class. I hope everyone have understood the concepts of the scalar product or the dot product.